Welcome to Odyssey Through the Universe. The moon's creation has fascinated humanity since the beginning of time. From ancient myths to modern science, the stars and the moon has captured our collective imaginations. Let's explore the leading theories and what they've taught us about our closest celestial neighbor. The moon has played a crucial role in Earth's history. Its gravitational pull stabilizes Earth's tilt, leading to a stable climate over millions of years. The tidal forces it creates are also significant in shaping the environment and possibly aiding in the development of early life. In ancient times, people wondered about the moon's origins. Some believed it was a deity or a manifestation of spiritual forces. Scientists have long debated theories, like the moon being a captured asteroid or a piece of Earth. Today, we know much more thanks to advances in technology and science. According to various moon origin myths from around the world, the moon's creation is often steeped in intrigue and cultural significance. In one popular story from ancient Greece, the moon, known as Selene, was considered a goddess who drove a chariot across the night sky. Meanwhile, some Native American tribes believed that the moon was a wise old man who lit up the darkness of the night. In other cultures, like Japan, it is said that the moon holds a mythic rabbit, tirelessly pounding rice cakes. These myths not only aim to explain the presence and phases of the moon but often imbue it with symbolism, attributing its influence over tides, emotions and time. Each myth, while different, highlights the universal fascination and reverence humans have for the moon as a celestial body that governs the night sky. The giant impact theory is the leading explanation for the formation of the moon, proposing that it resulted from a massive collision between the young Earth and a Mars-sized body, often referred to as Theia. This cataclysmic event is thought to have occurred about 4.5 billion years ago, during the formative years of our solar system. The immense impact would have ejected a significant amount of debris into Earth's orbit, primarily composed of material from the outer layers of both Earth and Theia. Over time, the remnants began to coalesce and accrete due to gravity, eventually forming what we now know as the moon. This theory is supported by several lines of evidence, including the composition of lunar rocks, which are remarkably similar to Earth's crust, and the angular momentum and inclination of the Earth-Moon system. Additionally, lunar samples lack significant amounts of volatile substances, aligning with the idea that the extreme temperatures from the impact would have caused these elements to vaporize. The giant impact theory not only explains the moon's composition and orbit but also sheds light on the dynamic and chaotic processes that characterize the early solar system, painting a picture of a world shaped by dramatic celestial events. Evidence supporting the giant impact hypothesis comes from lunar samples brought back by the Apollo missions. These rocks showed chemical compositions similar to Earth's mantle yet distinct enough to suggest a colossal impact. Computer models also support how such an event could lead to the moon formation. While the giant impact hypothesis is prominent, there are alternative ideas. Some suggest the moon formed from multiple smaller collisions, or that it and Earth formed together in a double planetary system. These theories face challenges, particularly when it comes to explaining the moon's specific characteristics. The capture theory postulates that the moon was an independent body traveling through the solar system when it was gravitationally captured by Earth. This theory struggles to explain the similar isotopic compositions of the Earth and Moon and the improbable circumstances required for such a capture event to be stable and result in the current Earth-Moon configuration. According to the double planet hypothesis, Earth and the Moon formed together as a double system from the protoplanetary disk. While this addresses the compositional similarities, it fails to explain the current angular momentum and specific aspects of the Moon's orbit and lack of a significant iron core. The fission theory suggests that the Moon was once part of the Earth and was flung off due to the planet's rapid rotation. However, the physics of this scenario are highly unlikely given the current understanding of rotational dynamics, and it lacks evidence such as the means by which the Earth could have achieved such an extreme rotational speed in its formative years. While interesting, these alternative theories have significant shortcomings when measured against the available geological and isotopic evidence, which makes the giant impact theory the most widely accepted explanation for the Moon's origin, enough to suggest a colossal impact. Computer models also support how such an event could lead to the Moon formation. Recent missions and discoveries, such as evidence of water ice at the poles, continue to intrigue scientists. Future missions aim to uncover more secrets of the Moon's history, which could also shed light on the broader processes of the solar system formation. The lunar exploration is set to become a major focus. NASA's Artemis program aims to return humans to the Moon by the mid-2020s, with plans to establish a sustainable presence. This initiative will help in studying the lunar surface in greater detail and could provide insights into the Moon's formation and evolution. Additionally, international and private missions are planning to explore the Moon's south pole, where permanently shadowed craters may contain ice, offering clues about the early solar system's history. These missions and studies will help us understand the Moon's origin and development, which will help us understand Earth's closest celestial neighbor. I thank you personally for joining us on this lunar journey. Our understanding of the Moon's origins showcases the power of scientific inquiry and exploration. If you enjoyed this video, please watch future videos and let us know in the comments what future topics you are interested in, and never forget to stay curious.